Dear students, in previous classes, we already discussed about three important tests for absolute convergency of a series. So they are limit comparison test, a ratio test and root test. What is limit comparison test? Limit comparison test is when r equals limit modulus of xn by yn if it is exists. Then if r differs from 0, then sigma xn absolutely convergent, if and only if sigma yn absolutely convergent. If r differs from 0, if r equals 0, then sigma yn absolutely convergent if and only if sigma xn is absolutely convergent. So this is limit comparison test. And what is a root test? Root test means that x equals xn be a, this is limit comparison test. And what is root test? Root test is let x equals xn be a sequence of real numbers. Then if r equals limit modulus of xn power 1 by n, if it exists, then if r less than 1, then the series is absolutely convergent, and if r greater than 1, sigma xn diverges. If r less than 1, sigma xn absolutely converges. Sigma mod xn converges, that means sigma xn is absolutely convergent. If r greater than 1, then sigma xn diverges. If xn equals 1, if r equals 1, also test fails. What is the important one is another, it is a ratio test. The third one is ratio test. So these are the three important methods. Limit comparison test, a root test, and the third one is ratio test. What is ratio test? If r equals limit modulus of xn plus 1 by xn, where x equals xn be a sequence of reals, then if r less than 1, again sigma xn absolutely converges, and if r greater than 1, sigma xn is diverges, not absolutely converges. So these are the three important tests: limit comparison test, root test, and ratio test. So by using these tricks, now let us discuss the convergency or absolute convergency or non-absolute convergency of some series. So here, first we consider the series. Sigma n ranges from 1 to infinity, n factorial by n power n. Check whether the series is absolutely converges or not. How? So n factorial by n power n. So here let xn, what is xn? Xn equals n factorial by n power n. Then what about xn plus 1 by xn? Xn plus 1 by xn equals, what is xn plus 1? It is n plus 1 factorial by n plus 1 all power n plus 1. This is xn plus 1. Okay. All by xn means it is all divided by n factorial by n power n. So it is n power n by n factorial. Agree? So there is nothing but n plus 1 factorial by n factorial, that is on numerator remains n plus 1. N plus 1 into, sorry, here is what means n power n by n plus 1 all power n plus 1. N plus 1 factorial. So it is nothing but n plus, here n plus 1 remains, here again n power n by n plus 1 all power n. Clear? All power n plus 1. So 1 n plus 1 again cancelling each other. What remains? It is n power n by n plus 1 all power n. So it is n plus n by n plus 1 all power n. What is n by n plus 1? N by n plus 1 means you can cancelling n each other. So it is 1 by 1 plus 1 by n all power n. Okay. That means we have from there, what is xn plus 1 by xn? Here it is given, we already obtained xn plus 1 by xn equals 1 by 1 plus 1 by n all power n. 1 by 1 plus 1 by n all power n, that can be rewritten as 1 by 1 plus 1 by n power n. Clear? So what about its limit? Now taken letter, so therefore modulus of this one is modulus of this one. Clear? Therefore limit modulus of xn plus 1 by xn equals limit of modulus of this one. What is its limit? It is 1 by e. 1 plus 1 by n all power n. We know that limit 1 plus 1 by n all power n equals e. So it is 1 by e. Okay. So it is 1 by e. What is e? E greater than, e lies in between 2 and 3. E greater than 1. Therefore 1 by e less than 1. Means here what is r? R less than 1. What is r? Limit modulus of xn plus 1 by xn. So by s by ratio test. Here r less than 1. Therefore sigma xn absolutely converges. That means sigma n factorial by n power n is absolutely converges. Agreed? Okay. Now consider another result, another series. Check whether the next one is, check whether sigma 3 power n, sigma 3 power n into n factorial divided by n power n. Check whether it is absolutely convergent or not. 3 power n into n factorial by n power. How? So let xn equals, let xn equals 3 power n into n factorial by n power n. Okay. So what about xn plus 1? Xn plus 1 is 3 power n plus 1 into n plus 1 factorial all divided by n plus 1 all power n plus 1. You can replace n by n plus 1. Therefore, xn plus 1 by xn. What is xn plus 1 by xn? Xn plus 1 by xn is, it is 3 power n plus 1 into n plus 1 factorial divided by n plus 1 all power n plus 1, okay, into, now what is this 1 by xn, that is n power n by 3 power n into x power. Sorry, it is n power n, not x power n, it is n power n. Agreed? Okay. That equals 3 power n plus 1, 3 power n, 3 remains on numerator. Agreed? N plus 1 factorial. So it is, what is xn? Xn is 3 power n, so it is not a, sorry, it is not n power n, it is n plus 1, sorry, it is n factorial. Sorry, there's a mistake. It is n power n by 3 power n into n factorial. Okay, sorry. So it is 3 power n plus 1 by 3 power n. Remains 3. N plus 1 factorial by n factorial. Here on numerator it is n plus 1. Clear? Then n plus 1 all divided by, what means n plus 1 power n plus 1, and on numerator n power n remains. Agreed? N plus 1 and n plus 1 power n plus 1. So it is remains 3 into n by n plus 1 all power n. Agreed? That equals, that means, sorry, or that equals 3 into 1 by 1 plus 1 by n all power n. Therefore, limit modulus of xn plus 1 by xn equals, takes a limit. When you take the limit, so 3 into, what about the limit of this one? 3 by e. That is limit of 1 by 1 plus 1 by n all power n is 1 by e. So it is 3 by e. What is 3 by e? 3 by e greater than 1. Okay, since e lies in between 2 and 3, because e lies in between 2 and 3, therefore 3 by e greater than 1. That means here r greater than 1. So by ratio test, then sigma xn not absolutely converges, means it diverges. Clear? So we may consider another series. Suppose sigma, consider the series so that xn equals n factorial by xn equals n factorial by 1 into 3 into 5 into etc. into 2n plus 1. Check whether xn is, the series xn is absolutely converges or not. How? Here xn equals n factorial by 1 into 3 into 5 into etc. into 2n plus 1. So actually, what about xn plus 1 by xn? Again by using a ratio test. Xn plus 1. What is xn plus 1? Here on numerator it is n plus 1 factorial divided by 1 into 3 into 5 into etc. into 2n plus 1 into 1 term also there. Replace n by n plus 1. So it is 2 into n plus 1 plus 1 means 2n plus 3. Okay. Divided by xn. So that is on numerator it is 1 into 3 into 5 into etc. into 2n plus 1 divided by n factorial. Clear? Okay. That equals, all of these terms are cancelling each other. What remains there? N plus 1 factorial by n factorial remains n plus 1 on numerator divided by 2n plus 3. That equals, it is 1 plus 1 by n divided by 2 plus 3 by n. We can cancelling or take n as common factor on numerator and from denominator can cancelling each other. What remains? 1 plus 1 by n by 2 plus 3 by n. So take limit. Therefore, limit modulus of xn plus 1 by xn equals limit modulus of 1 plus 1 by n by 2 plus 3 by n. What I get? It is 1 by 2. 1 by 2 less than 1. Then here r less than 1. That means sigma xn is absolutely convergent. Sigma xn is absolutely convergent. Okay. Right. What about the convergence of the series? Sigma n by n plus 2 into n plus 3. N plus 2 into n plus 3. You can test the convergency by using a limit comparison test here. Why? We know that n square always less than n plus 2 into n plus 3. That is true for every n following. That is true for every natural number. N square strictly less than n plus 2 into n plus 3. That is true for every natural number. That means, therefore, 1 by n plus 2 into n plus 3. 1 by n plus 2 into n plus 3 is strictly less than 1 by n square. Clear? 1 by n square. That means, n by n plus 2 into n plus 3. That is strictly less than n by n square. What is n by n square? It is 1 by n. So finally, n by n plus 2 into n plus 3 is strictly less than 1 by n. Okay, strictly less than 1 by n. Therefore, sigma n by n plus 2 into n plus 3 strictly less than sigma 1 by n. But what is sigma 1 by n? Sigma 1 by n is a harmonic series. It always diverges. Sigma 1 by n diverges. Therefore, by comparison test, sigma n by n plus 2 n plus 3 is always diverges for every n fallen n. Clear? Okay. What about the convergency of n by 2 power n? That is the next one. Consider another series sigma n by 2 power. Sigma n by 2 power. How can I test it? N by 2 power n. Here, we know that our letter xn equals n by 2 power. So what is xn all power 1 by n? Xn all power 1 by n is n by 1 power n by 2. Okay? N power 1 by n by 2. Sure. Therefore, limit modulus of xn all power 1 by n equals, applies the limit, it is 1 by 2. Why? Because limit n power 1 by n is 1. So it is 1 by 2. What is 1 by 2? Less than 1. So here what is R? R equals 1 by 2 less than 1 means R less than 1. So by ratio test, when R less than 1, sigma xn is absolutely converges. Okay. You can prove it by using another one. By ratio test. It is xn, n by 2 power n. Xn plus 1, n plus 1 by 2 power n plus 1. Then again you can rearrange it. So, but by using a ratio test, here limit modulus of xn all power 1 by n is 1 by 2, that is less than 1. So by ratio test, it is absolutely converges. Agree? Okay. What about the convergency of sigma 1 by sigma 1 by square root of n into n plus 1. N into n plus 1. Is it absolutely converges or not? Sigma 1 by square root of n into n plus 1. How? Here 1 by square root of n into n plus 1 equals 1 by square root of n square plus n. You can open the brackets. It is 1 by square root of n square plus n. So 1 by square root of n square plus n, it is strictly greater than 1 by square root of n square plus n square. Sure. Okay. That is that equals 1 by square root of 2n square equals, come on, equals 1 by root 2 into n. Agree? So means, therefore, sigma 1 by square root of n into n plus 1 greater than sigma 1 by, or sigma 1 by root 2 into n or 1 by root 2 into sigma 1 by n. Agreed? What is sigma 1 by n? Sigma 1 by n is a harmonic series. Harmonic series is always diverges. Therefore, by limit comparison test, the given series is diverges. By limit comparison test, the given series is diverges. Okay? Right. So what about the convergence or divergence of sigma 1 by n square into n plus 1? Sigma 1 by n square into n plus 1. Check the absolute convergence or divergence of the next another series sigma 1 by square root of n square into n plus 1. How? So n square, if you take outside, it is n into root n plus 1. Okay, other form 1 by, consider this one, 1 by square root of n square into n plus 1 is same as 1 by square root of n cube plus n square. Agreed? Okay, n cube plus n square. 1 by square root of n cube plus n square, which is strictly less than 1 by root n cube. Agreed? Strictly less than 1 by root n cube. Sure. 1 by root n cube means 1 by n power 3 by 2. Okay. So, therefore, sigma 1 by square root of n square into n plus 1 strictly less than sigma 1 by n power 3 by 2. What about the convergence of the term on right side? We know that sigma 1 by n power p converges if p greater than 1, diverges if p less than or equals 1. Okay, 3 by 2 greater than 1. Therefore, the series on right side is converges. Therefore, by limit comparison test, it is converges. Hence, it is absolutely, sigma xn is absolutely convergent. Agree? Okay. Now, what about the convergence of check the convergence of sigma minus 1 power n by, minus 1 power n into n by n plus 1. Try yourself the absolute convergence or check whether the series sigma minus 1 power n into n by n plus 1 is absolutely convergent or divergent. Okay, thank you.